Hey Tonisha, so I thought it would just be easier for me to go ahead and walk you through some of the questions that you missed. All of these questions, all of these things were in the lectures, so it may have just been something that you missed in the lecture. Some of them go a little bit, well, I was going to say some of them go a little bit more, but really all of these things were covered in these lectures. So I think you just maybe need a little refresher on what was talked about in those videos. So in the first two questions that you missed, it was just asking for an equivalent fraction. So number 1, for instance, says 1/5, and I want to know what that is out of 30. If you remember in the lecture, we talked about whenever we're trying to find an equivalent fraction, we're trying to find a fraction that's equal to the first one, but just with a different amount. So it's almost like, again, if I had a pizza that was cut into 5 slices, eating one of those is a pretty decent size slice of pizza. But imagine the exact same size pizza was instead cut into 30 slices. So they're skinnier slices. How many would I have to eat in order for that to equal that one when it was cut into 5 slices? So what we have to do is think about whenever we're changing a fraction, whatever happens to the bottom also has to happen to the top. Anytime we're changing a fraction. So in the bottom there, when we change the 5 to 30, we have to think about what was multiplied by that 5 in order to make it 30. A way to think about that, if you just take 30 divided by 5, we know that that's 6, is a way to think about that. Or maybe you know off the top of your head that it's 5 times 6 that gives us 30. So 5 times 6 is what gave us that. So because we multiplied by 6 at the bottom, we're also going to have to multiply by 6 at the top. 1 times 6 is 6. So the answer to that should be 6. Let's see, number 2 was very, very similar. We were looking for the fraction, let me get this out of the way. The fraction was 2/3, and we want to know what that is out of 6. So 2/3 equivalent to what out of 6? So what we had to do is, again, think about what we multiplied by to get to 6, and we're going to have to do the same thing up here to the 2. Well, 3 times 2 is what gives us 6. So therefore, we'll have to multiply by 2 at the top, and that will give us 4. So the answer to number 2 would have been 4 for that reason. Let's see, you got numbers 3 through 7 correct, so you did very well on that. Looks like we then missed number 8. So let's go take a look at number 8. So number 8 was an addition problem. So to add, what we have to do is we take these two fractions, 6/7, and then it's adding kind of a large fraction. I don't think I'll have anything as large as this on the quiz, so you don't have to stress on that. Now, anytime we're adding, whenever you see plus or minus in operations with fractions, we always have to have the same denominator. So what we just did in those previous two questions, we have to give them the same number. Now, in the fractions with the denominators that we have right now, we have 7 and 35. They're obviously not the same denominator, so we have to make them the same. And that's where we come across the common denominator. In the lecture, I talked to you guys about how common denominators are common multiples. So what we do is we look at all of our times table here. So for 7 and for 35, I am going to multiply, again, times 1, times 2, times 3, times 4. I'm looking at the times table for both these numbers. When I find the very first number that they have in common, that's going to be my common denominator. So thinking about our 7s, and I'll do this real quickly. You won't have to do this every single time. You might, off the top of your head, already know what this is, but here's where this comes from. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 20. Oh, that's a 7. 28. And 7 times 5 we know is 35. Now, you might already off the top of your head go, wait a minute, that's one of our denominators. Therefore, it's going to be a common multiple because 35, when I go down to that one, 35 times 1 is 35. So therefore, that's the first shared multiple that they have, therefore making that the common denominator. So that's where that comes from. So what I'm going to do is I'm going to go ahead and just erase all that madness down there. We know that our common denominator is 35, and that's where it came from. So what does that mean? What we have to do is we have to take that denominator, and we're going to make both fractions. have that denominator. So they both have to be something over 35 in order for us to be able to add these two fractions together. Now the great thing about that second fraction, so the 23 over 35, it already has that denominator of 35, so I don't have to change the top number. But like we did in those first two problems, in the first fraction here, whenever I change that denominator, I have to change the numerator the exact same way. So in this case, the denominator was originally 7, and we've changed it to 35. So like we did in that last problem, we have to think, okay, well, again, what did we multiply by 7 to get to 35? Well, I multiplied by 5. So therefore, we're going to have to do the same thing to the 6. 6 times 5, we know, is 30. So therefore, our new fraction is 30 over 35. And although it does look like a new fraction, it is equivalent to the 6 over 7. So therefore, we're still adding the same fraction, but we're able to easily add that fraction since their denominators are the same. When we add fractions, the denominator just stays as is. We just simply add the numerators together. 30 plus 23 is 53. Now, on the quiz, I know in the lecture I told you guys that you don't want to leave it in improper fractions, but I'll tell you, I'll take either. If you go ahead and reduce this to a mixed number, meaning that if you take 53 divided by 35 with a remainder, you're going to end up getting a mixed number. But the homework here was simply just looking for the improper fraction. So it does say just to type a whole number or a simplified fraction, and the fraction that it was looking for was just 53 over 35. So that was the total answer, or that was the end answer there. Like I said, on the quiz, though, I'm going to take either or. So if you want to stop there at the improper fraction, that's okay. But if you go ahead and reduce it to the mixed number, like we're doing up here, that is totally fine too. It's totally up to you. So let's see. So it looks like you had something very, very similar on number 9. Number 9, it was the same thing. You had two fractions that were different, and you had to find the common denominator. And it was a mixed number first. So let me show you. When we have something like this, we have 5 1/7 plus 2 over 11. So with that 5 there, anytime you have in an addition problem, anytime you have whole numbers as that in that fraction, or in that problem, I should say, you can leave it as is. You just come back and get that at the end. You can actually focus on just the fractions first, add those two together, and then come back and get your whole numbers at the end. So with our fractions 1/7 and 2/11, 7 and 11, if you looked at all the multiples of 7 and all the multiples of 11, the very first one that you're going to have in common is 77. So as if we just multiplied those two numbers together. So what that means is we have to change both of our fractions here. In order to get from 7 to 77, we multiplied by 11. So therefore, we'll have to do the same thing to the top. 1 times 11 is 11. So remember, whatever we do to one fraction, or I'm sorry, to the bottom number of the fraction, we have to do the same thing to the top. Now, over here in the second fraction was a little bit different. In order to get from 11 to 77, we multiplied by something different. We multiplied by 7. So therefore, we'll have to do the same thing to its top number and multiply it by 7 as well. So 2 times 7 is 14. So when we add our two fractions together, 11 over 77 plus 14 over 77, remember the bottom number just stays the same, 77. We just add the numerators together, the top numbers. 11 plus 14 is 25. Remember, we always want to look to see if we can reduce that, and we reduce it by dividing the two numbers by the same thing. 25 and 77, though, however, don't have any common factors. I can't divide those both by the same thing, so that is in my reduced form. I'm not completely finished with my answer, as I do have to go back and get that whole number, so my completed answer is 5 and 25/77. So that's kind of a weird fraction, but that's the answer that was looking for. Okay, so it looks like, let's see, then we missed number 12. Number 12 was a subtraction problem, but it looked like it was a subtraction problem where we maybe had to do some borrowing. In this one, we have 9 and 5/7 minus 3 and 6/7. Now, the great thing about this problem is our denominators are already the same. As I mentioned, in any addition or subtraction problem, we can isolate those whole numbers, come back and get those at the end. So we're going to ignore those for right now and only focus on our fractions. So 5/7 minus 6/7. Now, the problem with this, I can't subtract these two numbers. I run into a slight problem here. Obviously, I cannot take 6 from 5 because 6 is bigger than 5, so that doesn't make any sense. I would end up with a negative number. And we're not going to end up with a negative fraction here because of the fact that the first whole number is bigger than the second one. This whole fraction is bigger than this one, so we should be able to easily subtract them. What we're doing here in blue is we're simply just trying to do a little shortcut by subtracting our fractions first. Unfortunately, we have a little bit of a problem here and we can't do that. So, no, I didn't mean to erase the whole thing. So what we can do, we talked about in the lecture, we talked about two different ways that you can approach this. One, you could use borrowing. What we do in borrowing is you borrow from the first whole number, and we're going to end up adding to the fraction to make that a little bit bigger. Anytime we borrow, we always just borrow 1. And if you need to go back to the lecture to watch this, go look at the borrowing part. But we borrow 1 and make this 8. That 1 that we just borrowed from the 9, we're going to add that to the fraction. So the common misconception here is everybody wants to go, oh, okay, we just add 1. Well, adding 1 to 5 is actually like you're adding 1/7 to 5 because you've simply just added to the numerator. 1 as a fraction, so this is incorrect. 1 as a fraction can be written as one number over itself. Meaning that, and I'm going to write this just down here in yellow, like 4/4 is equal to one whole, one whole number there. So it's like one whole pizza. If I had 4 out of 4 slices, I had the whole thing. If I had 8 out of 8 slices, I had one pizza. So anything over itself is always equal to 1, even if it's like 127 over 127, yeah, that's 1 too. So it doesn't matter what number over itself we use to represent that 1. However, since our common denominator is 7, we might as well use that. So what I do with that 1 is I simply write it as 7/7 right next to the 8. So what we have right here is 8 and 7/7, which is the same thing as 8 and 1. Well, 8 and 1 is the same thing as 9, right? So all we've done is kind of rearranged that 9 to turn it into a fraction. Now, remember the 9 is not by itself in this number. Remember 9 is also added by, or is also together with that 5/7. So all we have to simply do is just add the 5/7 in there with it, and this whole thing right here still represents the 9 and 5/7, but just in a little different way. What we're looking at now is 8, and then if we add those two fractions right there, 7/7 plus 5/7, we get 12/7, which seems strange that we've made it kind of a weird whole number with an improper fraction, but that is going to allow us to subtract the 3 and 6/7. When I subtract my whole numbers, 8 minus 3 I know is 5. And then I can easily subtract my fractions now. 12/7 minus 6/7. Remember the bottom number stays the same. I just subtract the numerators. 12 minus 6 is 6. So my answer would be 5 and 6/7. I know that sometimes this seems a little bit tricky. Like I said, I recommend going back and watching the subtraction part of the lecture because I did get into borrowing. This doesn't happen every single time. If it was 9 and 6/7 minus 3 and 5/7, if those two fractions were reversed, I wouldn't have to do that because I could take 6 minus 5. That would be fine. It's just when that second fraction is bigger than the first fraction, I can't subtract those on its own, so we had to come up with a different way of doing that. So borrowing works that way. Another way that you can look at the borrowing, or the way that I sometimes think about it, in the event when you get to this point, when you borrow, a real easy way to borrow, or really kind of way to, kind of quick method that shows you what I just showed you was how that works. But a kind of shortcut, if you borrow from the whole number, make it one less. So in this case,